Today I am joined by James Loach, Head of Research for Siemens and Senseye Predictive Maintenance. Welcome, James.
Yeah, hi.
So before we kind of jump into the main topics here, can you give me a little bit about your background and your current work at Siemens and Senseye?
Right. Okay. Yeah. So I have quite a varied background. I began in experimental particle physics, solar neutrinos and dark matter, that kind of thing. So it's on the experimental side, so developing hardware and doing data analysis and model building and all of that kind of thing, right? And so that ended up stretching in Europe, Canada, North America, and I eventually ended up as physics professor in China. Okay. And about 6 years ago, I decided to move outside of academia and return to the UK. And that's when I ended up joining Senseye and becoming more focused on, data analytics, machine learning, AI, and so forth. Okay. So that's actually the majority of the time that Senseye has been around. So I was one of the early employees. Okay. And during that period, I've basically been responsible for the analytics. Okay, so for developing all of the algorithms, and the conceptual structures that they sit within, and I've also been part of the product leadership team because it's one of those products in which the analytics and the user interface and so forth have to work sort of nicely together, right? So yeah, I've also been on the product side a little bit as well. Okay. Okay. So Senseye in the early days, all the way up to acquisition by Siemens, which is now almost 2 years ago. And yeah, I'm still in that role, getting used to Siemens and taking advantage, I guess, of the opportunities that Siemens presents us to grow. Right.
Yeah, I mean, it sounds like you've had a really interesting career, physics professor in China to head researcher in the UK again. That's pretty amazing. But can you tell me more about what Senseye is, how it started and what role AI and machine learning plays in the tool itself?
Okay, so, I mean, it's normally a predictive maintenance tool, okay? At Senseye, I guess we define predictive maintenance quite broadly, okay? And in effect, what our tool is about sort of optimizing the usage of your maintenance resources, and in particular, the attention of the maintenance engineers, okay? So the principle behind it, right, is that it's monitoring sensor data from machines, okay, of all different kinds, and it's designed to be agnostic to the source of that sensor data and the type of data and the type of machine, okay. So it's analyzing that data in conjunction with information about previous maintenance, so work events that have been done on these machines, okay. And then it's acting as a sort of a decision support system where it's working with the user to help, using the sensor data and the context to focus their attention on the assets that need it at any point in time. Okay. So it's a decision support, attention management kind of system, and it's agnostic to machine.
I see. So that kind of decision support is that where the AI is kind of coming into this, because it's helping to, it's basically in order to support the decision, it kind of has to make a decision on its end too, wouldn't it?
Yeah, I mean, absolutely, right. I mean, so the machine learning comes in at different levels, okay. And I would say up front, we use a combination of all different kinds of machine learning techniques as well as a lot of traditional statistical techniques as well, okay. And these are at different levels. So, we basically have a bunch of systems which are looking at the sensor data as it comes in and kind of analyzing that in a sort of local context, right. So trying to look for things in that data that might potentially be of interest, so some unusual spikes, a trend, different things, right? Okay, this is kind of marking up the data, and then you have a system which sits on top of that, which looks globally, so across all of the different assets that the person is monitoring, and yeah, and as I said, tries to focus their attention on the things that, the behavior that most merits it. Okay, yeah. So those first set of systems, you have a lot of parallel pipelines, right? Yeah, like I said, different statistical machine learning methods, and then the system that sits on top of that is something like a recommender system. Okay, so yeah, it's trying to learn, what kind of behavior on assets gives good feedback on alerts, right? And just give the user.
Yeah. So like,
Yeah.
what's a problem, and what do I need to learn to see, to pick out and spot, and then present to the people who can do something about it, basically.
Yeah.
Not really different from training like an employee to look at like a gauge or an incoming set of statistics that say, oh, if I see numbers above this here, then that's a problem and I need to do something about it.
Yeah. Yeah. And it has to be in this paradigm because of the generality of the system, right? That the system cannot absorb physics and engineering information, right, for all of these different machines that it's monitoring, right? And if it could do that, and that was the idea, it would be not scalable, to tens or hundreds of thousands of different assets, right? Or it would be very, very expensive to scale, right? So because it lacks that physics engineering information, this detailed context, it's got to learn what matters another way, and the idea is to learn from the user, right? And so yeah, you can think of the AI as just doing many things, right? You can think of it as sort of like you said, it's you can think of it as some kind of agent, like a kind of colleague, right? That lacks the common sense of a typical maintenance engineer, right? But has got certain skills, like the ability to look at everything at once and notice very subtle things. And so forth, right? Yeah, I mean,
right.
Yeah.
Okay, so I guess we've been talking a little bit about predictive maintenance now, and how is that different from a normal maintenance system? And is this something you can achieve without machine learning and AI, or is it really kind of a specific application that requires those new technologies?
Okay, so I guess predictive maintenance, narrowly defined, at least in my head, would be about looking at the data and having models that sort of tell you when these machines are likely to fail. Okay, so that you can order the parts and schedule the maintenance at the right time before that happens. Okay, so it's all sort of future focused like that, and precise, and about sort of scheduling of things. Okay, yeah, like I said, Senseye really does look at things slightly more broadly than that. We do have functionality that's designed to predict, when machines are likely to fail. But most of the value that people get from the system is coming from, some more general functionality. So the ability of the system to spot odd things, things that have not happened before, right? That you can't reasonably predict, or whatever, know in advance. Yeah, and just learning from the user in some informal way about what kind of things maintenance engineers want to look at each day and what's useful and what's not. So it's sort of broader like that, right? And if you think about the extent to which machine learning is used, we say some things about that, right? So traditional predictive maintenance, to me, and there's this massive academic literature on this, it's all about people making specific models using some machine learning technique to predict when some type of machine will fail in some situation. Okay, and it's just full of diverse and some sense interesting machine learning, right? But like I say, we're not doing that style of thing, right? Okay, so when you're not building dedicated models and you're doing this general purpose thing, well, okay, so certain aspects of, how to say, right? I suppose the first sort of stage of our system, a lot could be done with statistical techniques, right? But machine learning, obviously, I don't know, in many cases, just a more efficient and flexible sort of way to do things, right? And then when you're looking at recommender systems and what have you, I suppose machine learning, it's a more sophisticated version of things we would call statistical methods. It's like a fuzzy line between the two, right? Something we might go into talk on later, though, is about language models and generative AI and all of that, right? That is a very nice fit for Senseye as a decision support system, okay? And yeah, obviously that is serious machine learning that enables you to do things that cannot conceivably be done with other methods. And yeah, language models in particular is a very nice fit for Senseye. Yeah, we're a decision support system. We have all this text labels on different things. We have all our observations on the data, and just searching through that, figuring out what the user would be interested in and expressing that to them concisely and neatly and contextualizing it in their local language, right? Yeah. And this is perfectly suited for that. So as I say, okay, to answer your question, you could do a Senseye type app using a lot of statistical techniques without much machine learning. But you have these tools available and they make things better.
Wouldn't you be also running into an issue then of, like, if you were to just do this entirely with statistical methods, where you'd have to basically manually code in every kind of edge case and every scenario, and it wouldn't be as adaptable to different tools and different applications and deployments? And it's just kind of the impression I'm getting from your current tool, that it's kind of designed to work with, you just set it up and it just can run on a huge swath of different machines or processes or whatever it needs to monitor.
Yeah, I mean, I think that's just correct, right? You just have greater flexibility in those models in using machine learning to pick up on patterns in the data and give you better models of normal, right? And better models of what people care about and all of that. Yeah. I mean, of course, it's central to what we do, and we're glad it exists and it makes our life easier, right? But Senseye is not fundamentally about some magic new deep learning technique we came up with, or some super crazy giant magical model that we built, right? It's extremely pragmatic system that just uses machine learning when it's useful and it adds value, right? But I mean, again, I can expand on it a little bit. I mean, I think that the reason that we have scaled and we've been successful at addressing a problem that is intrinsically very difficult to scale is because of very pragmatic, sensible choices, right? About putting the complexity in the right part of the product, right? Understanding where the value really comes from, understanding the role of the user, and having the UX and the analytics work well together. So, I mean, I think of Senseye definitely as a product, right? And there's a sort of a systems approach. And things surrounding the actual product as well that support it. Yeah, rather than a machine learning thing with some with a UI attached to it or something like that, right? If that makes sense.
Yeah, I think I understand what you're kind of getting at here. That you've, rather than the traditional focused approach, you've taken a much broader approach. But you're focusing your efforts on areas where it really matters and where it's really going to impact the user and their experience using the tool the most, rather than trying to build those, like you mentioned earlier, those really specialized like systems that can look at one machine specifically, and then you'd have to do that for all of your machines. You've created a general system that can just be deployed and used. It won't reach the same level of, like, this machine is going to fail in 24 hours or like 22 hours and 18 minutes or something.
Definitely. And I suppose we've always thought it's a massive distraction to go down that direction. It's like in any sensible run factory, machines are not failing all the time, right? Mm-hmm. You get very few examples of failures, right? And then like in our experience, very often these failures don't look like each other either in the data, right? It may be the same thing, but it shows up in different ways. And then you're dealing with all kinds of different machines with these handfuls of examples. And if you focus all your attention on trying to crack that as some kind of deep learning problem, it just doesn't go anywhere, right? It's like you really struggle to provide real value to people in the general purpose setting. I don't know. Yeah. So, we consider that to be something that we've avoided, right? In favor of things which, just kind of more realistic in the real world and provide more day-to-day sort of value to people, right? Than, a model that maybe has lots of promise attached to it, and this and that, right? But yeah, I don't know. Like, I mean, to me, like monitoring the machines, it's like you know, you're sort of like yeah, you just want to make sure things are kind of okay, right? And if there's sort of unusual things going on, you kind of want to be told about that and sort of know how often it's happened before and what kind of things that might relate to. And yeah, that kind of looks okay, and we leave that for a while, and maybe it will bubble up again in a few weeks if it's still going on, right? You sort of have this sense that it's like the system is like acting as eyes for you. It kind of knows what you care about, it picks it up, it's monitoring everything, and you just kind of trust it that when odd or strange things happen, that you will know about it, and they will be a good use of your time. Yeah, and then you can do your inspections and things, right? Yeah, I feel
Right, right.
it's like a colleague, right? And that, yeah, it's really strange to talk about things, but it's sort of like a colleague, and yeah, like a box that sits in the corner and is designed to throw out numbers for when each machine is going to fail, right? And only does that 1% of the time, and is not that accurate. That's not a very useful kind of, that's not like the picture we have in mind, right? And that's very often what these kind of systems turn into, right? In practice, outside of academia.
Yeah, yeah. It's an interesting kind of notion to think about here, because it's like you said, machines aren't failing all the time. So why would you make a system that's designed specifically to look for the failing machines when instead you could be looking for a system to make sure that the machines you have are running correctly, and then it doesn't necessarily pick out a failure. It's just picking out when it's not running correctly so that it can highlight that for you.
Yeah, and we like this quote that things that have never happened before happen all the time, right? And Senseye
Yeah,
very good
absolutely.
for that class of thing, right? And maybe we might talk about this later. I don't know, but it really is it's a general purpose balance of plant kind of system, right? You really wouldn't. It wouldn't be the right system for your jet engine or your nuclear power plant, where it's worth hiring loads of scientists and incorporating all of the engineering and physics knowledge and doing all the testing and all of that kind of thing, right? And of course, factories often have assets like that they want to provide that much attention to, and that's fine, right? But Senseye would give you that certain amount of value on these kind of assets. They're not as good as a team of data scientists dedicated to that machine would do, but the same system you can just connect to everything in your factory, right? And that, I think that's just very nice, right? It means that you can focus your data science effort on the handful of machines that really need it, right? And then you have this thing that you can trust to basically look after everything else. Yeah. That's again
Yeah, it makes
how
sense.
it's often used and how we think about it.